All right, so if you guys look up here, we'll try and finish this thing up, okay? So what I want to know for the radius, I need to know the distance between the point along that line and its corresponding point along the arc, right? So if we use the distance feature, right, and you say point A is the point along the curve, or along the, along the line. And then we take the points from the curve and feed that into point B. Oops. Pay attention. Look up here. So if I feed that into a panel, do I get something that looks like it could be a set of increasing and then decreasing radiuses? Yes. Okay, so if I plug that into there, I now have all of the math required to kind of create that. All right? So the last thing that we have to do in order to finish this off is to take the prime meridian, right, and use a command to create rotated copies of it all the way around. In Rhino, what would that command be called? Polar array? So it would be an array, and there's two versions, right? There's a rectilinear array and a polar array. So see if you can find a polar array in here. Okay? I'll pause this while you guys search for that. All right, so I'm going to resume this thing because I want to try and finish this portion of the definition up. All right, so the command is polar array. It's the same exact thing as it is in Rhino. So read the inputs. Geometry. So what geometry are we trying to create a polar array of? What's it called? Yeah, it's an arc. It's the prime meridian. So we go looking around for arc over here. Do we find arc? Is this it? All right, so let's try and send that over into geometry. Okay? All right, so then it did some, right? And so the next thing is plane, and it's already created a plane right there at the origin. Okay? So the count is the next thing. So what is, if we want the meridian lines to be 15 degrees apart, like the lines of latitude, how do we figure that out? Not the same. What was the value we used before? 15. It was 15, but into what? How many degrees do we take 15 into? Into 180. Now, is this 180 or is this 360? Okay, so then if we want 15 degrees all the way around, what do we get? 24. So you take 360 and divide it by 15, right? So 24. You could make this more automatic, right? So like, for example, isn't this giving you 15 degrees over 180? So couldn't you take that value and multiply it by 2 and feed that into the count? Or so let's try that. Go to the math department, operators, multiplication. Right? We'll take this one, feed it into here. I'll put a panel with a 2 on it. And I will feed the result into count. There is my lines of latitude and longitude derived mathematically inside of Grasshopper. Okay? Now, here's what you guys got to do. You guys have got to open up your old definition, get rid of the param that contained the drawing that you made of this, and replace it with this. Now remember, it needs to inherit the ability to decline. It also needs to inherit the ability to rotate around the sun. right? Because we have an adjustable angle of declination and it also rotates around the sun. Okay? All right, so I'll leave that at there and I'll let you guys work on that. It's also break time if you guys want to take a break right now. It's a good time to take a break.